Hello everyone, this is a lecture on the second derivative test. In the past lectures we learned about first derivative test, and this one is called second derivative test. It says let f prime at c is equal to 0, or let f prime at c be equal to 0, and let f double prime, the second derivative, exist on an open interval containing that number c. Then there's three possibilities here. If the second derivative at that point c is greater than 0, which means positive, then we say that f at c is a relative minimum. But if the second derivative at c is less than 0, meaning it's negative, then f at c is a relative maximum. As you see, this second derivative test is a fast, quick, shortcut way to find the relative maximum minimum values of a function instead of applying the first derivative test, which was a bit longer than this one. If f double prime of c is equal to 0 and it's neither positive nor negative, then this test in particular fails, and we have no choice rather than using the long method of finding local maximum minimum points, which is using the first derivative test. That's the test need to be used. But if f double prime at c happens to be positive or negative, we can use this shorter test, easier test, to determine the relative maximum minimum points of a function. We have a cubic function here, as always, so I'm going to take the first derivative. That would be 3x squared minus 12